Welcome back to your bone remodeling lecture part 2. We're going to pick up right where we left off at step 6. These two steps are called reversal, and it's basically what it sounds like. You're going to reverse the process that was happening before, where osteoclasts were destroying bone, and we're finally going to start building new bone. So here, precursors to these cells are going to appear. They're going to proliferate or increase in number, and they're going to differentiate into the cells that are actually going to do the job. So the cells they start out as are mesenchymal stem cells, which are the cells that will become all types of connective tissue. They all start the same way before they differentiate or they specialize into becoming osteoblasts. So anytime on your wheel you see an osteoblast or a precursor to something called an osteoblast, I like you to color it in green, just so you're very clear visually on the difference between the osteoclasts and osteoblasts. And when I say osteoblast, I mean a very particular type of cell. This is critical to know, where osteo is a prefix, of course, means bone, and then blast as a suffix is going to mean builder, essentially, and hopefully that's an easy one to remember. B for builder, blast. And this is the exact opposite of an osteoclast. Whereas osteoclasts eat away and destroy bone, osteoblasts go forward and build bone. So now that the reversal has happened, you're ready to go. As you might imagine, you start the steps called formation, steps 8 and 9. Looking on your wheel, we're going to color in those mature osteoblasts in green. And at the surface of the burrow, they're going to start essentially pooping out this substance that's called an osteoid, which is a soft, non-mineralized matrix. So this organic stuff that they're pooping out, please color it in yellow here, as noted. And this is not yet really bone. This is maybe 50% of what makes up actual mature bone, but it's soft. It's non-mineralized, so it doesn't have calcium and phosphorus in it yet. And what it is a matrix. So let me pause here to make sure that you have these notes. The pre-osteoblasts are matured into actual osteoblasts. They're releasing a substance called an osteoid. And when I say matrix, I don't mean that iconic movie released in the 90s starring Keanu Reeves. The matrix in this sense is best understood as a framework or a scaffolding or an outline of what's to come. So what I'm highlighting in yellow might be what you can think of as the osteoid. This is an organic substance, which means that it's carbon-based. It's made by your body. It consists of collagen, fibronectin, other very specialized proteins. And when you add on into this process minerals, which are non-organic, which are essentially what make up rocks, and these are going to be your calcium, your phosphorus, these more dense elements into this osteoid matrix, you're going to get what is actually bone. So again, osteoid is this framework made of organic proteins, things that you've made out of carbon that your body can make, and you add in these minerals, and you go through this process of calcification, which would of course be the next step. So take a moment, flip to step number 10. We are almost finished, and you're going to color in again this substance, this osteoid, in yellow. The new matrix in step 10 is going to be mineralized or calcified with these two minerals. You know that one major function of bone is to store minerals like calcium and phosphorus, and this is how it happens when you start mineralizing this osteoid. And you'll notice the change in the coloring on my slide between 10 and 11. And that's supposed to show you the difference between the non-mineralized bone matrix, the osteoid, with the matrix that has minerals in it, newly mineralized. And that's going to slowly become harder over time as well. When you get to step 11, the next step, this is a state called quiescence. And make sure you're able to pronounce that. So I'll say it again. Quiescence, quiescence, quiescence. And this looks an awful lot like the word quiet, as it should, because this just means a state of rest a state of stability. Nothing is really happening. You have some mature cells here called osteocytes that are going to steadily maintain the bone, and this bone is set for a while until something is activating it, like physical activity, and this whole process starts again. But at this point, your process of bone remodeling is finished. I'll leave this up. If you're already done writing the notes, follow along in your wheel with me as I go through the steps one more time. So we're looking at step 1, which is activation. Some sort of physical or mechanical stressor is causing these precursors to come into the cell. These pre-osteoclasts fuse into one giant cell with a bunch of nuclei, and they're going to eat away at that old bone through these steps called resorption, releasing calcium into the bloodstream. Maybe you need it. And then they're going to leave, and through a process called reversal, your mesenchymal stem cells, which are what starts all connective tissue, they're going to differentiate or specialize into osteoblasts, forming new bone in a step conveniently called formation. So those osteoblasts are secreting or pooping out this yellow substance called osteoid. It's not literally yellow, of course, which is an organic substance that's going to form the framework or the matrix. In step 10, you're going to add in those minerals, the calcium and the phosphorus. At this point, you're taking calcium from the bloodstream and you're adding it into the bone. And you can think that if you don't have enough calcium to begin with, then this process of mineralization doesn't happen as well. You might have weak bones. And then finally, we stop at a state of quiescence, of quiet, of stability, of having bones be at rest. So at this point, if you're finished with this slide, go and look at the true and false questions on the next page just to sort of process all this information you just learned. Great job.